Can I ask you a question?
Yeah.
I know we're going to review, but on our radar transfer plotting sheets, I know you've mentioned this before, but how do we know for the distance scale on the upper left hand of our of the plotting sheet? How do you know which one to use when it's 0 to 6 or 0 to 12?
You want to use the zoomed in as possible,
Okay.
but you know, if you're using the 12 or 24 scale and you have such a small triangle, it's going to be really hard to see. So you
Okay.
want to be zoomed in as possible, but I'm going to say 90% of the things that we are using are on the 12-mile scale. That
Okay.
we have a range and bearing of like 10 or 8 or 9, something 7 over 6, basically, but under 12. So it kind of tells you in that what's your bearing and range. Like, oh, okay, I'll use this, you know, that scale or whatever. But 90%, maybe even 95% of them are going to be the 12-mile.
Okay. Okay. Because I feel like we've used the 6-mile one before
We might have, yeah.
in class. And so you said it depends on what the bearing is?
The range, when you get the bearing and range of a target, it'll say like, you know, at 12 o'clock, the target was 045 at 10 miles.
Yes.
It was 044 at 7.5 miles. That's kind of telling you what scale to use.
Oh, because it's like, so I was reviewing one from your, like our recorded session. So it was like, one was at 10.3, one was at 7.4. Okay, so that makes sense.
So you can't even plot that on the 6-mile, right? And if you plot it on the 24-mile, it's just going to be so close that your lines are going to be real, real small.
I see. Okay. So when it's, okay. Thank you. I know you've said that so many times, but now that I've like
done it, it makes more sense. Yeah.
Yes. Thank you.
Cool. Well, I did, I guess I'll start on some announcements here. So on your quiz today, you can use your notes, and I just wanted to point out some notes for you. So if I'm going to share screen to the Canvas. So I'm on our Canvas page. Right, if I go to home, you could click on any of these and it brings you to the PowerPoints. You can totally go back to the PowerPoints and look at those. But I also wanted to show kind of the quick guides. So under, my mouse is weird, sorry. Reference material, they are step-by-step guides. How to plot the first triangle.
I was looking at those today.
Right here. So it gives you your acronyms and then kind of a step-by-step of how to plot the first triangle. How to plot multiple targets. We're going to get into that one today. But then there's also, sorry, I'm going all over the place. Go back to this page. At the bottom of the homework, I guess I should have put up the other one. You have the radar plotting sheets, as well as examples of paper plots. So you have the first triangle illustrated and the second triangle illustrated. So that second triangle illustrated kind of gives you somewhat color-coded of a what that second triangle should look like as an example. So just good, you know, notes if you get stuck and can't figure out which ones are M or E or whatever it is. Those are some good little guides. So definitely check those out.
Was that in modules?
So I just clicked on modules. If you go to the home, and you could click, I'd like to click homework, I guess I tend to, because it brings me to the homework section, which I have the example of paper plots. And then at the very bottom, I have my reference material.
Okay. Thank you.
And since I'm here, if you click on the Zoom, it brings you to the Zoom. You have the Zoom link and then the Zoom recordings. So these are the links to each recording for our Zoom class, for classes sessions. And then of course, if you go to Bree's tutorial videos,
But
I was having trouble with the privacy thing, but I think it's all worked out. You should have, pause this here. What was this one? This was this week's homework, last week's homework, etc. And the Zooms will be on here as well, but you can go through that. Okay. Any questions so far? Okay. I was hoping we get a couple more people on here. Hello. All right, I'm gonna do a step-by-step review on how to do first and second triangle, and then we'll kind of dive into the quiz. So let me share my screen. Okay, so I've come up with a little question. It's from one of the homeworks or something. But just so you can see, we have our own ship, course and speed, and then the target at 2 times with a range and bearing. And for the quiz and for the homeworks, what I did, you want your CPA, your time of CPA, the target's true course and speed. We decide who's give way and stand on. And then we want new course or new speed for our new CPA. So that's how the quiz will be formatted, and that's how we'll do a review. Okay, so the first thing I do is plot the heading flasher, or whatever my course is. So that is 0, 0, 0 in this case. Okay, I moved it. And I'm going to have my own ship is 0, 0, 0 at 17 knots. Great. Then I'm going to plot what they told me. 1920, I have a bearing and a range. 1926, another bearing and a range. So I'm going to plot these. 062 at 9.8. All right, so I got 9.8 on my dividers. So this guy, I'm going to label R, and that was at 1920. Erase it a little bit. So that was my first one. Then I have 1926, another range and bearing. So this was 062. No, 063, excuse me. At 8. .3. So there's 8.3. So that second dot I'm going to label M, and that was at 1926. So from the information they gave us, we have an R and an M. So then I'm going to connect R and M and create my relative motion line. So this is my relative motion line. So from looking at my relative motion line, if both of us maintain our course and speed, then he is going to pass behind us, but still pretty close, definitely within this 2-mile CPA that we want. But just so you could see how that how he crosses behind us instead of in front of us. So now I want to figure out what my CPA is. So I like to figure that out by doing a right angle, the relative motion line. So this is the closest point of approach. This is the CPA, closest point of approach. So if I want to figure out the distance, and that's what we want to do for our first question here, is what is the CPA? So let's look at our distance for the CPA. I have 1 nautical mile. So I'm going to say my distance is 1.0 nautical miles. Next, I want to figure out my time of CPA. How quickly is this going to happen? Do I have a lot of time to think about it, or do I need to get thinking about it now? Let you guys catch up for a minute. So for CPA, that was a right angle that I did there. Now to figure out time of CPA, I'm going to use the speed of relative motion, which is which I'm just kind of walk what happened in 6 minutes and project it out along the way. So I'll get the distance that the relative motion traveled in 6 minutes. And then I'm just going to mark that same 6 minutes until it passes my CPA. Okay, so I'll fill it out. This is where we like to do quick math. 26 plus 6 gives us 32, 38, 44, 50, 56, and that would be 2002. Is that right? Yeah, 2002. So we had 1920 going along, then we had 1956, in between 1956 and 2002. So I might call it 2000. I'll call my CPA 8 p.m. there. So we haven't even plotted the one triangle yet, and we've already solved 2 out of the 6 questions. So we did CPA, 1 mile, 2000 TCPA. So we already got 2 of them down for not even a triangle yet, just the relative motion line. So now I want to figure out, I'm not comfortable with this CPA. It's too close. Am I the giveaway vessel or am I the stand-on vessel? I want to figure out what their true course and speed is so I can figure out what situation we're in. So I need to plot my own course and speed in order to get their course and speed. So my own course is 0, 0, 0. And we're going to plot that over to R. So we're going to bring it over to R. So that I can create an E to R line. So I've created the line. Now I need the distance. My speed is 17 knots. So that means in 6 minutes, I'm going to go 1.7 nautical miles. So we're going to go find 1.7. Wow. There we go. And now I can mark an E. So I've just created a line that is E to R. If I look on the bottom, that's my own ship. So E to R is 0, 0, 0 at 17 knots. R to M was my relative motion line. So E to M is them, is the target's course. So let's find the target's course. I'm going to connect E and M, and then I'm going to bring my roller down so I can read it. Okay, we'll call that E to M. I'm going to bring it down. And I'm going to call the target's course and speed. The target's course is 3. I have a big dot for my M. So the smaller your dots, the better. So now I want to figure out what my target's speed is. So I'm going to get the distance traveled in 6 minutes and convert that to speed. So my distance traveled is 1.5. So my speed is going to be 15 knots. I go back to this guy. I'll write in my course. So this is what they call the first triangle. We've plotted what their speed is and what our CPA is. So that's 2/3 of the way done here.
For determining your position, the E, if your heading was not 0, 0, 0, because that's what you transferred over, right?
Correct.
Was that heading? Say your heading was, I don't know, 290, let's say.
Mm-hmm.
would your E then be like more in line with,
So if your heading was 290,
uh,
well, let me bring it like this. Your heading's 290. You just bring it over to R
gotcha.
and create that E vector. It's going 290 at
Got
such and such distance.
Perfect. Okay, now I understand.
Okay. So, now we want to figure out, this is what I'm doing. This is what he's doing. This is a meeting situation. And he is on my starboard side, meaning I need to give way and let him pass ahead of me. So I need to turn to starboard and let this CPA line, even though it's closer to passing behind me, I need to bend it all the way so it passes ahead of me. So that's going to be a bigger course change. So let him cross ahead and I'll get the stern. So we're going to do a course change. It tells us our MX is at mile 6 and our CPA is 2 nautical miles. So here's 2, 4, 6. So this point here is going to be my MX, the point where I'm going to maneuver. So maybe we'll call it 1935-ish if I had to call it a time, but that's going to be our MX. I don't have to call it a time, I'm just complicating things. So now I want to create a line from my MX crossing my bow or my heading so that they cross in front of me and at 2 nautical miles. So just tangent close to this, as close as I can get to the 2 nautical mile circle without touching it. Or I guess touching it, but anyways, you know what I mean. So this is going to be my new relative motion line. So I have a CPA of 2 nautical miles, and I am going to be changing my course or executing this move at 6 mile MX.
Can I ask you a question really quick?
Yes.
I even if I think I know the answer, but just by me stating it out loud, like MX, it says 6 mile. Did you put 6 mile there because of the circle, right? Like 2, 4,
Correct.
6. Okay.
Correct. If I could have measured the distance if I wanted to, 6 miles.
Because I think I did get confused when you said the time for some reason. You're like, I'm just confusing things. I was like, I think that's where I got thrown off.
And
but.
you need to stop just throwing information at you.
No, I mean, all of your information is so helpful, but I just take things, I just analyze it.
So yeah, you could just say, when is he going to cross 6 nautical miles? But because we have that range ring there, that's 6 nautical miles.
Okay, and you always go to the 2 mile radius, the first 2 miles, that's where you draw the line?
It depends if they give us 3 mile CPA or it depends on the information they give us.
Okay.
So
okay.
Most of the time it's going to be a 2 mile CPA. We're going to come across some that are 3 mile CPAs.
Okay.
So if it's a 3 mile CPA, you have to draw in that 3 mile arc and then put your line to it.
Okay. Thank you. I think I was like trying to copy what you're doing when you brought that Post-it note back into the picture.
Okay. I'll leave it there.
Thanks.
Okay. So we have the new relative motion line. And now I need to bring that new relative motion line back to my triangle so I can create the second triangle. So I'm going to parallel it. So there's my line. I'm going to parallel. It's going from MX this way. I'm going to bring it back to M. So my MX is going this way. That's what I have on my roll plotter. And then I'm going to bring it back to M and draw it the other direction. So this is the same line, the new relative motion line. The new relative motion line. Focus it, seems blurry. Okay. So now I've created my new relative motion line. And I want to figure out what would be my new course if I did not change speed. And then what would be my new speed if I did not change course. So we're looking for both of those, but they would be separate maneuvers. I kind of want to make that clear. So we'll start first with if we maintain our speed of 17 knots, what so I'm creating a new vector. I know it's starting at E, and its distance is still going to be 17 knots. That's what I have for my E to R right now. It's going to stay the same. So I'm going to create an arc here, going to starboard, because I'm going to be turning to starboard. Going clockwise, I guess. You're always going to move your arc clockwise. And I know my triangle, E to M, I'm looking for my new triangle, that second triangle. E to M stays the same because they are not moving, or they are not changing course and speed. I am. So E to M stays the same. So I have my E, I have my M. I need to find where my R is going to be. I know I want it to be somewhere on this line, the new relative motion line. That's where I want my new triangle to be. So and I know the length of E to R is going to be the 1.7, what I just created there. So my E to R is going to be where those two lines intersect. So right here. That is going to be my R prime for course speed. So or course change, excuse me. So if I wanted to change course, that is going to be my new course. I'm going to bring it back to the center so I can measure it. And I got a new course. Call it 051 degrees. So I would be changing from 0, 0, 0 and coming right to 051 and letting him pass in front of me.
Can you review the last 2 minutes? Because I was writing stuff down.
Okay.
I get where the new R is, but
Okay.
how did you get the new R and then the line towards the end of the plot?
Okay, so I had my same speed, my 17 knots, brought it down to my new relative motion line. So my new triangle, I'm gonna do two triangles, sorry. For speed is on this relative motion line. That is my new triangle, right? My E, R, and M.
Oh, it's from E to the new R. That's where you got, that's.
Yes, so E to R is always going to be my own ship.
The E to the new R is where you got that.
To the new R, that's going to be my new course. My new course and speed. It's what my ship is going to be doing. I know my speed is going to be 1.7 because I didn't change speed. I
Mhm.
changed course.
Mhm.
So I measure, I connect E and R, whatever it is. I draw that line, and then I bring that line to the center so that I can measure it and get an actual course.
Oh, I see. Okay.
So
Thank-
even though this line, crosses the outside of the circle, we can't read it here because it doesn't start from the center.
Mhm. I see.
So that's a common mistake,
Yeah, I see.
to
And then
say our
I'm-
new course is, 066 or something.
And
We
then,
always got to bring it back and read it from the center.
and that new like 50, 51 is called what?
The new course.
New course. Okay. So now I'm just trying to think. I'm sure that's where you're going, but like if you put the boats back on there, and so you would change to 51 degrees.
Yep.
Okay.
So if I change course to 51 degrees and he continues along his way,
Mhm.
he will be passing
Captain Bree, you froze on my screen. I'm not sure if you froze for everyone else, but I'm sorry. It looks like she got cut out.
Sorry, guys. Are we all there again? All right, let me go back. Okay. So this was our new course change. So now our next step is, if we didn't change course, what would our new speed be? So if I go back to my triangle, my E to M doesn't change. That's what they are doing. And I know I want to be somewhere along my new relative motion line. That's where I want the boat to follow, here, and then go along my new relative motion line. And my E stays the same. So in order to create this is the second triangle we're going for if we are doing a speed change. So from E, my course did not change. My course is still 0, 0, 0, but my speed will change. The length of that, so we could create this point, is R prime again. So I get this distance, which will give me the new speed if I don't change course. to say I need to slow down to 0.9, so that would be a new speed of 9 knots. So that's new speed for 9 knots. So that's what this length is right there. Okay. So those are the 3 things, or the, 6 things actually, but there's kind of three parts to it. So part 1, we figure out our relative motion, our CPA and time of CPA. Part 2, or the second part, is we figure out the true course and speed of the target. So we plot the first triangle. And then the third part is plotting the second triangle. And we kind of plot 2 triangles for the second triangle. Option A and option B. Do we want to change course or do we want to change speed? Is there land over here? We can't even change course that far. Do we need to slow down? Who knows? So what are our options for creating that CPA that we want? But yeah, option A and option B. Okay. How you guys doing?
Good. You have a lot less notes on yours than I do, because I feel like I write everything. I'm looking at yours and I'm like, oh, she erased a lot of stuff. And I'm like, oh, geez, mine has a lot. But
No, that's good. That's good. That's
and
okay.
I keep running back to get more colors.
Well, if we look at the notes, right? Go back to this. Our second triangle illustrated. His is very simple, but we have the E to M. This isn't exactly the same question, but yeah, you could see his. Take your own notes, however you want to do it. Okay, Louise asked, why is the new relative motion, oh, let me bring it back. New relative motion line brought above instead of below. So that is by what we are doing. So we figured out with the original CPA that he is the stand-on and I in the give way. If I move his relative motion line back here, that means I am going to be speeding in front of him, or kind of essentially I'd have to change course. So I'm going to be darting in front of him. And we don't want to cross in front of a stand-on vessel. If we are the give way, we don't want to cross ahead of them. So even though it would be less of a course change, if we did that, because we already have 1 mile CPA, we only need to go another mile, it would be a lot less of a course change, but that would be essentially turning to the left and just crossing in front of them. We never want to turn to port. We always going to turn to starboard. And they're always going to cross ahead of us. If we are the give way, we're going to let them pass in front of us, meaning their relative motion line will be going across our heading. So they pass in front of us and we go to their stern. That's our rules of the road. So, yeah. Okay. Let's see. Cool. Okay. Any other questions? All right. Well, stop the share. the quiz is in Canvas. I'm sure you guys have done quizzes before in Canvas. I don't know. Let me bring it up. Here we go. So you can go to quizzes, and we're going to do that single contact paper plot. Oh, I need to be in student mode or something. Sorry. Student view.
It's pretty similar.
Okay.
I took a look at it. I didn't actually take it, but I did look at it. But what you just pulled up, it's pretty similar to that.
So yes, here's our quiz. We have your own ship, and then at 12 o'clock, we see a bearing and a range. And at 12:06, we see another bearing and a range. So same questions I just did. What's the CPA, TCPA, target true course, target true speed? Are you the stand on or give way? And these are actual, I guess I'd just say resume quiz. That doesn't make sense. Hold on. Leave student view.
It
Okay.
didn't look like that earlier. Like the questions were kind of like put in your own answer. It wasn't multiple choice.
Okay, good. I was like, that was a weird.
Like I
That
never
was kind of
saw
my
it.
test one when I was trying to figure out how to do quizzes, but I know I filled it all in.
Yeah, I took it, and it was all like you had to like type in your own answer.
Okay, okay, sweet. Okay, so it is 6:45. So let's try to do this. Jump back on when you guys are done. I kind of will check back in a half hour. If you guys need more time, that's fine. But I'm gonna check back in at 7:15.
I'll probably need more time, just letting you know. Like
Okay.
I'm just letting you know when you check in at 7:15. But when I'm done, I can, if I do finish before then, I can message you on chat saying I'm done
Okay, sounds good.
or whatever.
And I will be on here if you guys have a question.
Oh, okay. That's helpful.
So this isn't, I'm not trying to like punish you by anything. This is just, everyone's got to do it, right? Everyone's got to put pen to paper and do it. So that's what this is. Okay. Let's see if he's back. Cool. All right. So we are going to dive in to another subject. But definitely keep practicing this. The more you practice it, the more it will make sense. So there's lots and lots of practice on the homework and in-class stuff. So please, please go through that. Okay, so we are going to dive into radar navigation. And hopefully we will get to paper plots as well. Or yeah, multi-target paper plots. So here we're really trying to decipher what's on the screen and how we can use it to our advantage, right? So we have on the left-hand side here, we have these big, bold, green, curvy lines. And somehow that is land, and we want to figure out how to navigate using the radar. So we're going to talk about that. And then if we have all of these dots on the screen, how do we know which ones we need to maneuver for or be watching or monitoring? And how do we know which ones we can just ignore? So, so that's what we're going to be talking about today. So first we're going to dive into navigation. Navigating by radar, we kind of three main things. Position fixing or verifying your position. And that, most of you guys will have a GPS or something like that, some sort of electronic navigation on board. So using the radar really verifies that position that you're getting. So you kind of have this checks and balance with all those tools that you have on board. Your visual nav, your GPS, your radar, all these things you want to check and verify. So the radar helps us do that. It helps us for coastal navigation, especially, you know, if we're very close to the coast or in a river or something. It has great tools to help us navigate the river and stay on course and give us that instant feedback. Are we off track? Are we not off track? And then it helps us in reduced visibility. If we can't see the land or we can't see the aids to navigation to get visual fixes or anything, that radar sees through the fog and the rain, and even at night, sometimes it's disorienting. So that radar helps us kind of get our situational awareness back. Okay, so two main things we use in radar navigation is the EBL and VRM. Now, I've talked about those before when we are getting our range and bearing to the targets that we are acquiring and then transferring to the paper plot. So the EBL is the electronic bearing line, and the VRM is the variable range marker. So focus on the middle letter for bearing and range. It's a quick way. You can usually just move the cursor to get your range and bearing, or some radars don't have cursors, but you have to like toggle back and forth. Either way, it's usually a quick way to get a range and bearing either from a buoy to a target to a point of land to something, so you get those two LOPs that you could then use for navigation. So this slide is all about the most accurate way to use the radar for navigation is by using the ranges instead of the bearings. You guys remember why? So we have most accuracy on our radar with the time calculation of how fast it's moving. It hits an object and then echoes back and we receive it. The actual bearing, we kind of have, and we're going to talk about this today, distortion on how that beam is shot out and then comes back. It gets bigger and bigger as it goes out. So things that are farther away from you can have a little bit of distortion. Just rule of thumb, ranges are more accurate than bearings when it comes to radar. Again, a bearing is still pretty accurate, so I would go with it, but just keep that in mind. So what does a range fix look like? So if we have three ranges, so in this case, we have a range from this point, we have a range from this point, and we have a range from this point. And when we plot a range, if we are right here and we say this point is 2.15 nautical miles away from me, how I plot that on the chart is by plotting an arc of 2.15 miles, saying I'm somewhere along that line. Infinite possibilities, right? If I'm 1.4 miles from this point, I draw a 1.4 mile arc, etc., etc. So where those three arcs or lines of position, it's still line of position, meet would be our fix. So the closest they are to each other, the tighter that pinwheel. Do you guys know the terms pinwheel versus cocked hat when it comes to your positioning? Maybe? No, okay. There we go. So your typical fix is something like that, right? We have a buoy or a light, a buoy, and maybe a point of land or something. So typically, if you're getting visual ranges or even radar ranges, you're not going to get them exactly in the middle. Hopefully you are, but as a professional mariner, it doesn't happen. So when you get them exactly like that, it's called a pinwheel. When you get a triangle, which is 90% of the time, it's called a cocked hat. And I'm drawing it here with straight lines, but my point is LOPs come in all sorts of shapes and sizes, right? So we could have, we had 2 bearings, and maybe we can have a range give us something like that. So we have an LOP here, and a range, a curvy line here. So our triangle looks something like that instead of an actual triangle. Or we could have these 3, how am I going to draw it? 3 arcs, if you will. So you get a very curvy, I can't even draw it, curvy cocked hat. So I guess my point is just lots of different LOPs out there. You want to get them as close as possible for a more accurate position. But is that realistic? Not really in real life. Okay. So we're going to look at a bunch of these. And here's our steps for plotting a 3 arced, 3 radar ranges position. So first step to any plotting is you has to be on the chart in order for you to plot it. So even if you're getting a visual fix, a radar fix, anything, you have to correctly identify it on the chart and at what you're looking at. So you need to correctly identify that curve in the land that you are getting a range off of, or that Raycon buoy, or make sure it's not a boat, make sure it's not moving, make sure it's a buoy, make sure it's whatever it is. You need to correctly identify what you are looking at on the chart versus on the radar, or if you're looking at the window. Then you need to actually get your data, if you will. So you need to get the ranges using your radar or ranges and bearings, whatever it is, at the given time or whatever. Then you're going to draw the arc from each point on the chart in the vicinity of your DR. So you don't have to draw this giant circle across your whole chart. You can just draw an arc in the vicinity of your DR. You don't have to get all kinds of crazy lines over your chart. Wherever those lines cross each other is your location. You're going to mark that location with a triangle. That triangle indicates it's an electronic fix. I have a whole thing on like rating different fixes and identifying what they are. Hold on. Let me show that to you.
Captain Bree.
Yes.
I just wanted to let you know, since you're transitioning, that I messaged Captain Kevin and he said his internet's been really unstable, because I asked him, I was like, did you leave? I don't know if he messaged you, but I don't know if he's trying to get back in, but just wanted to let you know.
Gotcha. Thank you. Dang it. Sorry, bear with me a second. Okay, I am not finding it. Never mind, I was gonna go off into a tangent. I guess this is good, keeping me on track here. Okay. Anyways, you mark it with a triangle or whatever you want to use. So here's another example. This would be a pinwheel because they all meet in the exact same middle. But our first one, this arc here, is from the tank. So maybe we see a radar tank. It must be really high, so we can see that. The other one, this guy right here, is from Long Point. And then this guy right here is from the light. So wherever those three meet, you put a dot and you call that your fix. So that's our 1015 fix using radar ranges. But you can also use a range and bearing. And I'm going to say this is the most common type of fix people get and quickest to use because you only need one aid to navigation or one point of land or one anything that you're looking at. So a lot of times you use the Raycons because they're very identifiable, and we're going to look at some examples of those. But you just get your bearing. So when you use your EBL and VRM, you will see it will give you a bearing of 260 at a range of 9 miles. So you just plot your 260 and your range as an arc, and you can call that your fix. Here's another example of the ranges, 3 different ranges. So again, you want to correctly identify where they are and what you are seeing on the radar. And that's the tricky part because sometimes the radar doesn't exactly look exactly like our chart looks. So we want to make sure we're correctly identifying things. Okay, I think I've showed us enough of that. Also to keep in mind, when you have 2 ranges, 2 LOPs, it gives you 2 possible locations. So with an LOP, you're in infinite possibilities around or on that line. Well, if you're in infinite possibilities on those lines and that 2 lines cross in 2 different places, which arcs do, then you have 2 possible locations. So you need a 3rd piece of information. So that 3rd piece of information can be a lot of different things. It can be a sounding. It can be, am I north or south of this buoy? It can be, look out the window. It can be another bearing. It could be another range. It can be all sorts of different things. It doesn't have to be another range, I guess is my point here. If you get 2 ranges, you do need a 3rd piece of information because that will give you 2 possible locations. It doesn't always. Say your other range was somewhere over here. Those 2 points that will meet might be, 100 miles apart from each other, and it's pretty obvious about which ones cross or which one's closest to your DR line or all of those different things. But you do need to, use your navigator's mind to figure out which one you're in. So it's computer is not going to be able to do it for you. Okay. Then we have a 2 bearing fix. So we have a range and bearing, ranges, and then 2 bearings. So this is your standard bearing fix. Hopefully you've done it in Coastal Nav or something. where you have two bearings and you get your EBL to two different objects, whether they're buoys, lights, points of lands, or whatever, and you plot those two bearings, and wherever they cross is where you are. If you get a third, it's proving that your first two were correct, and that third is usually going to give you that cocked hat. So, okay. Kind of going through this quick, but that's okay. Our ranges are more accurate than our bearings. Okay. Now we're going to talk about parallel indexing. This is super important when it comes to navigating in coastal waters. So it helps. You can, I guess I'm going to show it to you and then describe it. Okay, so in this picture here, this main line, this bold black line here is our track line. So if we want to stay on our track line, then I can note from my chart that I want to maintain 0.6, I guess that's 0.6, yeah, 0.6 nautical miles away from this point of land. So if I put a line on my radar that is parallel to my track line, right? This line is parallel to my track line at 0.6 miles off to my starboard side, and I'm down here, that line should still be touching that little point of land. If that line is crossing over the land, that means I'm closer. My cross-track error would be to starboard. I'm closer to that point of land. If that line is further away, that means my cross-track error is to the left. I'm further away from that island than I thought I would be. So this is what it actually looks like on the radar. This is a parallel index line. If we want to maintain our course, and I want to keep this island however far off of my course, then I can be way down here and have that object be 12 miles away from me and still tell if I'm on my track line or not. So it's that instant look. I don't have to plot something on the chart. It's an instant look to say, am I on my track line or not? It doesn't exactly give me my position. It's just a visual, hey, should I come to the left or hey, should I come to the right? So that's where that coastal navigation, am I getting too close to land, really gives you that instant, no calculation necessary. It gives you that instant visual of where you are. If I click on the YouTube video, it kind of has it in setting it up in motion. It's a little slow though. It's getting closer. So as you move closer, okay, you guys can look at that if you want, but oh, can you guys see it? I'm sorry.
No, we can't see it yet.
Oh. Okay. It wasn't a good video. This picture, standing still, describes it better. There's too much jumping around. But as you get closer and closer, you can tell where that line moves relative to the land. This is another drawing of a parallel index line. So I want to stay on course 020. So if I draw in a parallel index line, oh God, back to the noises. We draw in a parallel, right? It's parallel to our course, and I have it offset by a certain distance that I've already noted on the chart. And I want to keep that line on the point of land that I've noted. So even if I pass it, I can still see that that point of land is right on my track line, meaning I'm on course. I'm to the right or left of course. Then we can also plot multiple parallel indexing lines. This one is for a new course. So if I set up a new course that has the lighthouse whatever distance away from me, when I get close, I want to then be following this parallel indexing line. So this, when this line gets to the lighthouse, that's when I want to change course. So these lines travel with me. It's the land that kind of moves down my screen. These lines stay next to me, where the land travels down, if you will, as you're moving. The land is moving as well. So when that line gets to the lighthouse, that's when I want to change course, where most likely you're going to want to change course slightly before that because we have our advance and transfer. Okay. Okay. Questions on parallel indexing lines? I feel like I did that pretty quickly, but they are really important. Oops. Does it make sense? Has anyone used a parallel indexing line before? Or even heard of them before? No.
I
I've heard of them. I've just never used them.
Okay.
Haven't used them. No questions yet.
Okay. They are a great tool. Each radar is a little bit different. Sometimes to put a parallel indexing line on the chart or put a parallel indexing line on the radar, it takes a little, menu diving, if you will. But once you learn your radar and how to put one on quickly, then they're great tools to use. So mess around with that if you get a chance. Okay. The next one we're going to talk about is tangent bearings. So a lot of times if you guys are going to do Coast Guard questions or anything like that, they have this thing called tangent bearings. So ignore this little paragraph so far. Let's just talk about what a tangent bearing is. So tangent means it's a line that crosses through an arc or circle just once. So if this line, you can see, passes through this arc or circle twice, and this line passes through it 0 times. So it's that point of tangency where it just passes through an arc once. That's what tangent is. So when we see a bearing, and this is to a piece of land. So if you have a bearing that is tangent to a piece of land, it is just crossing or just touching that piece of land just barely, just once. So it's not going all the way into the land, or it's not touching the land. It's crossing it just once. So in this picture here, we're going to look at the piece of land here. I think I go to the next screen. So my tangent bearing is it just touches the land just one spot. That is where I can get my tangent bearing. So this is an example of a tangent bearing off of the East End Light. Oh, I have lots of clicks. So this is our bearing line moving around, our ABL moving around our screen, right? It's moving around our screen. And so as it crosses here, we can see it doesn't touch. It touches 2 times. It touches 2 times. So we want the exact point of tangency where it just touches the land once. And that can give us an accurate EBL or LOP. Okay. now that I said an accurate EBL or accurate LOP, we are going to talk about how bearings have a little bit of difference. So because we have this horizontal beam width, you have a little bit of distortion when it comes to what your actual picture is and what your actual land is and what your picture is showing you. So it kind of gives us this blown out version of what the land is going to look like. So let's look at more pictures of that. So this picture here is showing us, showing us what, I'm going to put that on. If we are over here, we'll look at the first circle here. When we see our coastline, some of it is in the shadow. So we are missing this part of the coastline. We're missing this cove. So we don't know exactly if that's the point or not. And we're missing this whole section over here, right? The radar signals are coming out and going back in, but I can't go behind that mountain or behind whatever it is. So we do get this shadow of our coastline. And as we move, we've moved a little bit closer, we could kind of see the presence of a cove here because our coastline here is now broken. And we see a little bit of a coastline here and our coastline's broken there. So you can see a little bit more, but it's still a little bit distorted. On this one, you can see the difference between this island and the little point of land here. And you can see more texture or more distinguishing marks on the land itself. So keep that in mind when you're looking at those, green lines on the radar and how they can transfer to your chart. So you can correctly identify, oh, that, curve of the line is whatever point and whatever landmark. This bottom right hand shows a little bit of the horizontal beam width distortion. So that's our beam width distortion. So the further it gets away from us, the more distortion it's going to have. So you can see kind of the ones that are right next to us doesn't have that distortion. Where further away, kind of at the extremities, we do have a little bit of this, a little distortion in the coastline. So if we're getting a range or something up here, it might be a little off. So just something to keep in mind. You don't have to stay up at night worrying about this at all. But it's just something to keep in mind. Okay, I'm going to skip that one. Do I have a better picture? I like this picture better. So this is the same picture of the other one, but here we have what we're actually looking at, right? We have a mountain, a tower, a low sandy beach. This is the observer ship. We have a ship over here and a ship over here and a small island, another mountain. So on the radar, we get a few different things. We get that beam width distortion. And that ship one is also blended in because of that beam width to the coastline. So it's not distinguishing that those are two separate things. It's also not picking up the low sandy beach at all, but it is picking up that tower. So it kind of looks like a cove with a boat in it, where it is a low sandy beach. We do not want to go anywhere in there. And then we have distortion on beam width distortion on this side as well. It can't distinguish between ship number 2 and the land itself. And we can't see the island, the small island behind this piece of land because of that radar shadow. We can't see behind that mountain. So just other examples of the way we can get distortion on our radar screen. Okay. Any questions on that distortion? Radar effects. Okay, cool. Plotting by radar during fog and at night with low visibility is super important. So we're talking about it today. Today was a super foggy morning. And without seeing anything around you, it can be very disorienting. So knowing how to use your radar before it gets foggy or before it's nighttime is super important to help you with that orientation of what do all these lines mean? Where's the point of land that I'm looking for? So try to get used to it when you can still, see the land itself visually and on the radar and on the chart, because that helps when you're just blindly looking because of the fog or the rain or whatever it is. It can be very disorienting. Okay, entering a harbor. You'll probably have little buoy marks, and you can use those parallel indexing lines. But again, as you move, those buoys will be moving down. So those land or those stationary things move as you move the opposite way. A raycon. So a raycon is a radar beacon, and most raycons will be on a safe watermark. So that's kind of that entrance buoy to a channel, sometimes called a pilotage buoy. And that raycon will have, let's look at a better example here. So the buoy itself will show up on radar, and then it will give us this distinguishing mark after it. And that mark is a Morse code mark. So on the chart, it will say, this is buoy such and such. It's a safe water buoy, and it has a raycon that is, I think this is Victor, V. Oh, so it's a letter of Morse code. So it's going to be da, dit, 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 or, long, short, short, short. And that's what you're looking for on the radar to identify that raycon. So that raycon is going to be closest to you. And as you move, that raycon signal is always going to be away from you. So if you are up here, that raycon signal is going to be going this direction. Oops. Here's another one. This was a raycon that was Mike, long, long. Here's a raycon, long, short, long. Again, it's always away from you. So you're always going to see the buoy, and then you're going to see the raycon. It's moving away from you. Here's another example. So we have our buoy and our raycon. Has anyone seen a raycon before out there? There's one coming into Long Beach. Oops.
I have
The
not.
safe watermark in Newport does not have a raycon, but there's one in LA and Long Beach. And I think there's one in San Diego. I'm not positive. Okay. Then other weird things we're going to see on the radar is a SART. A SART is a search and rescue transponder. And they give you a series of dots, which as you get closer can turn into arcs or concentric circles. And the SART is always going to be closest to you. This is what a SART looks like. I want to say, I don't know, you tell me, have you guys seen these on board? Any of your vessels? A SART? Okay. So a SART is activated by a radar signal. So you want to keep it high so a radar signal can activate it. But these are more examples of what your SART is going to look like. So it's just a bunch of lines So it should be a very big like, hey, there's something on the screen that's not natural. All these lines are, parallel to one another. And that is going to be what a SART looks like. Again, you want to hold your SART up as high as possible. And the ship's radar is what is activating it, and then the ship can see it. So that is a SART. Any questions about navigation and using the radar? You guys all right? Okay. Okay, we're gonna dive right into multiple targets. Let's do it. Okay, so multiple targets. How do we determine all of these blobs on the screen, which target is dangerous? So, bear with me here. What makes a target dangerous? Meaning it's possibly causing risk of collision. We can determine risk of collision by our CPA, right? So if its CPA is getting close to us, that is a dangerous target. So our rules of thumb, when we call a target dangerous, it's the target with the closest CPA. And then if you have multiple targets with close CPAs that you don't like, which one is going to hit you first? Meaning which has the greatest relative speed. So you don't want to be maneuvering for someone that's going to hit you an hour out when someone might be hitting you 10 minutes out. So you want to maneuver for the one that has the closest, or the one that's going to get to you first, essentially, which has the greatest relative speed, or which is going to get to that predetermined maneuvering point first. So that is what we are going to think about when we are determining which target is more dangerous. Who is the closest CPA and who's going to get to that CPA first? This is the handout. I think it's on the reference material things. So again, who is the closest CPA? If both contacts are going to hit you, then which one is going to hit you first? Meaning who has the longest relative motion line, meaning going faster. Rarely, if ever, is a dead in the water contact the most dangerous contact. Yes, if a dead in the water contact is directly ahead of you, it's dangerous, but it might not be the most dangerous contact because its relative motion or its true speed is 0. Okay. So if we would figure out which target is the most dangerous, and we decide we've done everything we've been practicing, right? We've plotted our new course and we know how to safely avoid it and let them pass ahead of us. How will that course change affect the other targets around us? So we need to plot a new CPA for all of the other targets so we can determine, am I turning in front of another ship? Is this maneuver going to make a bad situation or another risk of collision with another ship? So after we do this whole, first triangle, second triangle of what we did on the quiz today, then we need, our next step is figuring out what the CPA is for all of the other targets with our new course change or speed change, whatever we decide to do. So how do we do that, right? We want to determine, first step, we want to determine the MX for all of the other vessels. So if my limiting factor, I was given an MX of 4 nautical miles, CPA of 2, right? That's what we were working with. Well, that MX is going to happen at a certain time. So I want to mark down that time of when I'm going to make that course change. And then I want to plot that on all of my other vectors. If I have 2 other targets, 3 other targets, whatever it is, I want to plot that time of that mx. So I know where that relative motion line is going to change. So I need to determine the time of the mx and plot it for all of the other targets. Then I need to transfer my e to r prime. So that's that new e to r, whether it's a course change or a speed change. I need to transfer that e to r prime to all of the other contacts' e's. So I'm creating a new triangle on all of the other contacts. And then I'll draw my line. Then I'm going to connect my r prime to m. That is creating my new relative motion line for the other contact. Then I'm going to parallel that r prime to m vector back to the mx so I can draw out the new relative motion line and get my CPA. So I'm kind of working that triangle backwards now. So we worked it one way and now we're working it backwards. I know this seems complicated. Okay, so let's look at it. Okay, so here we go. Here we had this is our dangerous target. So we had R, M, so our relative motion line goes directly through us. We don't want that. So we have a new relative motion line. We plot our new relative motion line. We're maintaining the same speed. So we have a new course. So e to r is my new course when I maneuver at mx. So this is what we've done today in the quiz. So next step is to figure out where that mx is going to be on the other relative motion line. So that mx is a time here. It's not a, maybe it was 4 nautical miles. It's not 4 nautical miles here. You're going to be changing that course at a certain time. So when is that time? And that's what we want to mark here for our mx. Then we want to transfer our e to r, our new course line. So we move it up to our other e, and we get our r prime. Then we're going to connect our r to r prime to get our new relative motion line. Okay, so there's our new relative motion line for that target. Then we're going to parallel it down to mx. Ooh, there we go. So that is our new relative motion line from mx. Then I can, same thing, perpendicular line from the new relative motion line to get what our CPA is. So this would be my new CPA for this target. So if I maneuver for this target, I get an even bigger CPA for this target. So we are good to go and we can make that change happen. I know this is a lot of lines. How are you guys following along on that?
I have a question, kind of, I know it's backtracking a little bit, but what does MX stand for again?
That's the point of execution, or the maneuvering execution point.
Okay.
That's,
it doesn't actually like M doesn't, like M and X don't stand for something.
no.
Okay. So I'm like NRML is like,
Yeah, new relative motion line.
relative motion line. And I know what it like does. I just didn't know if it meant something like, okay. And then R, when it's like R1, that means it's
The new
Right.
one, or R prime.
prime. Yeah, okay. But yes, a lot of lines.
Yes, very confusing. Okay, so now we're going to do a little bit of in-class practice. So I don't know if you guys already have this printed out or you just want to follow me, but we're gonna do our in-class practice. And then you have 3 homework assignments. You don't have to do all 3 by any means. I'm just trying to give you guys practice problems, right? The more you practice, the easier it will be and the less confusing. So you just want to go through the motions, use that, where is it? You know, step-by-step guide, follow along for each question, and the more you practice, the easier this will get. So yeah, practice, 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 up to you guys. Okay, so next week we are going to do a quiz on multi-target plotting. And then we're going to go over rules of the road. I realized rules of the road should have been like first. And then we're going to talk about a little bit about ARPA and the rest of our theory. So we're kind of wrapping things up next week. And then the following week after that is going to be all review. So we're just going to review theory and review all of our paper plots. So we get 4 hours to spend on reviewing with each other. And then the week after that is going to be our final exams. So any questions? Should we start with our in-class practice?
No questions, get started. I would love that. I'm gonna
Okay.
follow along like on my own.
Okay. And again, this will be posted. I literally just had it. What did I do with it? So you can go back and watch. Here it is. Okay. Zoom in here. Okay, so here we have targets at minute 0, and then we have what happened. So here we have something at minute 0, minute 0, minute 0. I got a range and bearing of all of these things at minute 0. Then 6 minutes, so this is what, if you just look at the highlights, that's what my radar screen looked like at whatever, 12 o'clock. 12:06, or 6 minutes later, my dots have all moved, and now it looks like that. So I want to determine, I see all these dots moving, which ones do I need to be worried about? So in order to do that, so we have our R and our M, R, M, R, M, R, M, R, and M. So our relative motion lines, we want to plot our relative motion line to see what's going to happen. So let's plot it.
Wait, Captain, how did you know which one was R and which one was M? You're just, because it was.
One was at minute 0 and one's at minute 6.
Oh, okay.
R to M, it's not moving. Okay. So if I'm looking at this, well, which target here is my main concern?
The R and M, one that's the same.
So we have D, E, A, B, and C.
And which way are we moving?
We are here headed north.
A,
A.
A. So our relative motion line of A gives us a CPA, a small CPA. I don't know what it is. I don't have a scale on here, but it gives us a small ETA. So this is just identifying which target we need to change for. So this is the target that then I can plot my first triangle for. I don't have a scale, so I can't actually plot that. But this is what I do my first triangle for and my second triangle. And then I can plot what happens on the other ones. So hopefully we get another one here that might have some more. So we have things happening at minute 0. And then 6 minutes later, we get more blips on the screen. So let's plot those relative motion lines and see what we get.
In a sense, this would be your trails.
Okay, so here we have this guy passing safely. This guy right on the edge of 2 miles, but pretty good. Then we have this guy coming within, so we have A coming within our 2 mile circle. We have B coming within our 2 mile circle. And we have C coming within our 2 mile circle. So we have 3 lines that are getting pretty close to us. Now, how do we determine which one is most dangerous? It's going to be which one hits us first.
Is it C? Sorry, not to jump the gun, but
No, it's not C.
okay. Sorry.
That's okay. So if this is 6 minutes, right? I have a distance here. Then I can do my little walking. 6, 12, 18, 24, 30. So let's say CPA for that one is about 30 minutes. Let's see this one. There's 6, 12, 18, 24, kind of about the same, about 30 minutes too. So those are going to be about the same. So if it was just those two, I would figure out which, I would plot both of them and figure out if I am the burdened vessel on which one and maneuver for that. This guy has a longer R to M line, meaning his relative speed, he's going to get to us a lot quicker. So this is 6 minutes. Sorry, 12, 18, 24. So he's going to get to us in 24 minutes, where these guys are going to get to us in 30 minutes. So even though he's further away, his relative speed is a lot faster, meaning he's going to hit us first. So he's our most dangerous. He's going to hit us first.
Can I ask a question? Sorry.
Yeah.
That totally makes sense. But like to the naked eye, could you like tell that because his is that R to M, the yellow to the orange? Because it's a little bit wider from his like 0 to 6. Would you know like, oh, he's coming, like he's going to be like coming towards you faster, like just without you even doing that with that?
Yes.
Work?
Yes, I can see that this line is bigger, so he's probably going to be more dangerous than either of these.
Okay.
Relatively speaking, they are not, moving as fast.
I see. Yeah.
So a lot of times you want to say, oh, the closest target is the most dangerous. but that's not necessarily true because B is the furthest away,
Mhm.
but he is coming to you quicker than everybody else.
Yeah, okay.
Okay. Do another one of these. Sorry, I thought I was going to sneeze. Okay, so we have happening at minute 0 and then happening at minute 6. So looking at this, I can see that these two are changing more rapidly than these two, but I don't exactly know their direction of relative motion or travel. So let's plot it.
This has definitely made the most sense so far.
Okay.
Like easily, like just relatively, just looking at it, not to, I don't know. I just wanted to see that.
Okay. So here we have target A. He's getting pretty close to us, and his speed is going to be pretty big. So he's a contender for most dangerous. B is getting close, but not that close, and he's passing behind us. But we can see his change of speed is also a lot smaller. So I would say A is more dangerous than B. C is not going to be hitting us at all, and neither is D. So it's in between A and B, and just by looking at it, I'm going to say A is the most dangerous target. Does that make sense? Okay.
Absolutely.
Cool. So now let's actually do a problem. I want to make sure I get the right one. Okay. So it is going to be a radar instruction manual. There we go. Okay, so we have 2 targets. We have our vessel 000 at 18 knots. The following observations were noted on the radar at 9. We have A and B targets, and then 6 minutes later, we have another A and B target. So let's plot it. Okay, so they told us our own speed, our own course and speed, 000 at 18 knots. So let's say own ship at 18 knots. Then we have at minute 900, 0900, we have a target A bearing 050 at 11.1 nautical miles. So we plot that out. So that is our R at 0900. For target A. So you'll put a target A next to it. Also at 0900, we had a target bearing 000 So right in front of us at 9. Okay, I have a crossing there. At 9 nautical miles. So this is target B. And this is my R at 0900 for target B. So I have A and B, plotted my R's. Then I'm going to plot 6 minutes later. 050 at 8.5. So 8.5. Okay. So here on my target A, I have my M. So I have my R to M. Target B, I need to plot 7.3. There we go. So here is my M. So if I connect, first step is to create my R to M line, my relative motion lines. So if I connect R to M, I get a 0 CPA. Right? It's crossing 0. If I connect this R and M, I also get a 0 CPA. So both of these targets are giving me a 0 CPA if we do not change course or speed. But which one is the most dangerous? So let's see who's going to hit us first. All right, so that's 6 minutes. So we have 6, 12, 18, 24, 30. So we'll call for target A. CPA was 0. TCPA was 24. Call it 25. We'll do the same thing for target B. So we have 6, 12, 18, 24, 30, 36. So their CPA, so target B, CPA was 0, but the TCPA, our time was, let's call it 33 minutes. So about 8 minutes later, they would get to us. So we need to maneuver for target A. Target A is going to be our most dangerous contact. Okay, so they give us an MX of 5 nautical miles and a CPA of 2 nautical miles. So when target A is 5 nautical miles away, that's when I'm going to maneuver. So we need to figure out when that is going to be. We don't have a 5 ring, so I'm just going to find it on here. So this is going to be my MX. What I didn't do yet was see rules of the road wise if I am the burden vessel in any of these cases. I jumped ahead to plotting my new maneuver, but I need to plot my E to plot my new maneuver in the first place. So let's plot E. Sorry, I skipped ahead there. Okay. Plotting E. We're transferring our course back to R. So our course is 0, 0, 0. We're going to move it back to R. And we're also going to move it back to this R, which I already have a line there. Okay. Then I'm going to plot my speed, which was 18 knots. There's 18 knots. So I'm going to plot my vector here. And I'm going to plot my vector here. So here is my E, and here is also my E. So in this case, my E and M are the same. What does that mean? They are not moving. That would be a dead in the water target. That's probably a buoy. But let's plot E to M. So I got a target course of 272 and a target speed of 20 knots. So let's look at the situation. Red flag is that this guy's off my starboard side. Don't know what he's doing exactly, but I need to figure out if I need to maneuver for him. We have figured out what he's doing, and I do need to maneuver for him. He's off my starboard bow. He is the stand-on. I'm the give way. This guy is not moving at all. He's dead in the water. So we don't really have, so I guess this would be an overtaking situation, but not really because he's just dead in the water. Probably have to just avoid it. Okay, so if we maneuver for this guy, how will it affect this guy is our question. First, we need to figure out how we're maneuvering. So we have an MX of 5 miles. And we have a CPA of 2. So I want him to cross ahead of me at 2 nautical miles. So we're going to create that new relative motion line. And then we are going to parallel that new relative motion line back to the other M. And we're going to get our 18 knots, still at 18. And we are going to turn to starboard. So here, where these two cross, is my R prime. So E to R prime is my new course. So my new course parallel that over. Say my new course is going to be, what did I get? 054 degrees. So now I want to see how that's going to affect this triangle. Even though this isn't really a triangle, so this might have not been the greatest example to start off with, but let's see. So my E to R is not going this direction anymore. My E to R is this. So I need to bring over this E to R prime over to the other triangle. So I'm going to bring over that exact vector. So that direction and that length. Okay. Bring it back over to where my E starts. And I need to put my new R in there. New R, oh, is my distance. Was our 18 knots. So this is my R prime. So now I have my E to R is exactly transferred over here. So here I have my relative motion line. Okay, so this is own ship, right? This is my new course. This is the relative motion line. So that's this guy. Because I want him to pass 2 miles in front of me. So now I need to create, where is that relative motion line on this triangle? Yes, it's not exactly a triangle because it's a line, but anyways, our R to M, right? So this was R prime to M. So R prime to M is that relative motion line now. This guy's relative motion line is not going to be this, it's going to be that. Now, how can I figure out where his new relative motion line bends? Is it's going to maneuver at his MX. So this MX, I didn't figure it out yet. This is 12. This is 18. I'm just getting what that distance is there. That was about 26, so half of that is 13. I'm just fine-tuning this a little bit. So that is minute 15. So we have 12, 15, 18. I just broke it down to 3 minutes. So I'm gonna call, if I had to break this into 3 minutes, I'm gonna call that 14. So at 9:14 is my MX. So where's this guy going to be at 9:14? Do the same thing to be a little bit accurate. 16, so call it 8. That's at minute 15. So minute 14 would be right about here. So I'm going to call that my MX. So this was at 0914. This was at 0914. That is where my MX is. So here it had to do with the 5 nautical miles, but here it had to do with the time because I maneuvered for this guy first before this guy got to the 5 nautical miles. Okay. So this R prime to M is the same line, right? R prime to new relative motion line. R prime to M is the new relative motion line. So R prime to M, this direction, is going to be the new relative motion line going from MX. So that is where I am bending this guy's relative motion line. So if I maneuver for him, I am not endangering this situation. I am increasing the CPA from 0 to 4 nautical miles if I maneuver for target A. How'd you guys follow along on that? Kind of, sort of. Let's do another one. Make sure it actually is changing here. Okay. Let's do another one. I don't know, any questions about this one? I feel a little bit hesitant moving on, but let's do it. Why not? Okay. So I'm on number 33. They are telling us we are on a course of 050. At a speed of 18 knots. So I'm going to say own ship 050 at 18 knots. Oops, there we go. Then they tell us at 10:11, we see a target at both of these again. 090 at 11.1 nautical miles. No, this is just. So this is R at 10:11 for contact A. Okay. Then we have our R for contact B, which is 065. I shouldn't have drawn it that way. 065 at 11 miles. So this is my R at 10:11 for target B. So that's what we saw at 10:11. At 10:17, 6 minutes later, we have 090 at 8.1. And 6.9. This one was 8.1. So this is going to be my M at 10:17 and 6.9. This is going to be my M at 10:17. Okay, so we have our R and M, R and M. So if we go back to these guys, what can we say about which one's the most dangerous target just looking at this? These
E.
R and M's are a lot closer together. These are further apart, meaning these guys are going to get to us a lot quicker than these guys. But let's plot it out. So we connect R to M to get relative motion. All right, CPA 0 and a CPA of 0. So it's not looking good for either of these targets. But what does our relative motion tell us? Let's time it out. That's 6 minutes. 6 minutes later, and 6 minutes after that. I'm gonna a little more careful here. Okay, so we have 17 plus 6 is going to be 23. Okay, so here was 10:23. Here is 10:26. Here is 10:29. So for target B, I'd say my TCPA is 26. We'll call it 27. 10:27. This guy's so we have 17, I already did the math here, 10:23. Oh, 10:29, 10:32, and 10:35. So I would say TCPA for target A is going to be 32, 33, we'll call it 10. We'll call it 1034. 33, 34, something like that. So target B is going to happen quicker, meaning that's the guy we're maneuvering for. Hopefully our maneuver won't put us in danger with him, but let's see. So we are going to maneuver for contact B. Let's plot our E's. So finishing first triangle. I plot my own vector, 0, 5, 0. And my speed is 18 knots. Clean this up a little bit. Okay. So here is my E, and here is my E. So if I look at them, their true courses, I am connecting E to M. So he's going that way, and he's going that way. So if we look at, I'm gonna need another boat. Uh-oh. All right, we have a jet ski. Here's our jet ski, headed this direction. And here is my other boat headed this direction. So both of these vessels are off my starboard bow. This might be considered a meeting situation or crossing situation, but when in doubt, assume it's a crossing situation. So either way, I'm going to have to turn to starboard, and I'm going to calculate it for this guy because he is my dangerous target. So hopefully by turning to starboard, we avoid this guy as well. Well, let's see what's going on. So, it gives me a MX. Let's see. What does it say? Oh, MX of 5 nautical miles with a CPA of 2. So same as the last one. I need to figure out when he is going to be 5 miles away from me. Target B, my most dangerous. Okay. So this is my MX. And I'm going to bend it to 2 nautical miles in front of me. So this is my new relative motion line. And now I'm going to bring that back up to this M so I can get what my new course is. Hopefully I made that far enough. Yeah, I did. Okay. So my E to R was 18 knots. Let's make sure I have 18. E to R was 18 knots. And we are going to turn to the right. So where this crosses is my new R prime. So my triangle now looks bring that down. I don't know why I started doing it with the triangle instead. There we go. Okay, so this is my new course. So this is my new triangle. Let's look at it. We had our, let's use the same colors I did on the last one. Don't know where my last one went, so we're gonna see. E to R, wait, yeah. E to R is my new course. So I'm keeping the same speed, but I have a new course, E to R prime. So I need to make that E to R prime over here and see what happens. I'm just using these triangles. I guess I am. Okay, so here's my E to R prime. I'm going to bring that down back to the E. And I have my same 18 knots. Yep, it's still here. 18 knots. This is my R prime. So these lines are the same. My E to R prime is my new course. So now I need to plot what my relative motion was. So here I had my relative motion line, R prime to M. That's the same as this line. So R prime to M is the new relative motion line. I see, you can't see that. R prime to M is our new relative motion line. So it started at MX, we brought it back here, and it was part of the triangle. So now we need to put that new relative motion line, figure out where it's going to be for target A, for this guy. So MX here happened at, let's call it 10:20. So I'm saying we're halfway in between these two, so I'm calling it 10:20. So where's 10:20 in this case? We'll call it halfway in between these. I'm not going to eyeball it. So here is 10:20, meaning this is my MX. So wherever I get, or here on this triangle, we haven't made the triangle yet, but we had R prime to M is the new relative motion line. So here's R prime, and here's our M. So let's connect R prime and M. And that is our relative motion line, our new relative motion line. Then I want to move that relative motion line to MX. Just like this relative motion line goes to MX, this relative motion line goes to MX. My tools. So I'm going to bring this line back to this MX. So here's our MX. Bring my line over. And that is my new relative motion line. So this course change will move both of these targets away outside of my 2 nautical mile CPA. Okay. A lot of times they'll ask, what is the new CPA for the new target? So relative motion line perpendicular. Use the triangle right. The new CPA is going to be well over 2 miles. About 2.75 miles is going to be my new CPA for the least dangerous target. Most dangerous target CPA will be exactly 2. Okay. How you guys feeling about these? I think we're going to call it a night. Get a lot of information today. So remember to practice. I will post this video again on Zoom recording. And then I'll probably finish this assignment as a homework tutorial. I'm not going to do all of the homework tutorials because I gave you a lot of problems to do. So if you guys have a certain question on one, email me, whatever, and I'll video it and do it, or we can do it in class first thing in class tomorrow. Next week. So bring your questions next week. I'm happy to do more examples before the quiz, and I will grade the quizzes by tomorrow. So look for an updated score for your quizzes, and I will make the try not to get this autocorrect thing for the next quizzes or for the exam. I'm going to figure that out. It's on my list. All right, that's all I got. All right. Any questions? You guys good? See you next week. Have a good weekend.
All right. Bye, Captain. Have a good weekend.
See ya.